Okay, we're going to take a look at how parallel and perpendicular lines show up as we're doing equations of lines. Um, as you know, parallel lines, they just run side by side, they never intersect. And perpendicular lines intersect at 90-degree angles or right angles, and that's kind of a big shot in the world. 90 degrees or perpendicular is a big deal. Just take a look around at the walls and the floor and the ceiling. You'll see a lot of 90 degrees. All right, so if they are parallel, these lines end up having the same slope. That makes sense because they have the same steepness. What makes a little less sense is perpendicular lines have what's called the opposite reciprocal slopes. And here's what we mean by opposite reciprocal slopes. 2/3 has a reciprocal of 3 over 2, and the opposite sign means if this was positive, I call that negative. Negative 3/2 is the opposite reciprocal of 2/3. Negative 4 has a reciprocal. Now you wouldn't necessarily notice it at first, but negative 4 is like a negative 4 over 1. So the reciprocal of 4 over 1 is 1 over 4. And since we have to do the opposite reciprocal, that is positive 1/4. So here's what that's meaning. If in this little example up here, the slope of this line, just going to make something up, let's say it was 2/7. That means the slope of this line, because they're perpendicular to each other, has to be opposite, positive slope, negative slope, 2/7, 7/2. So when you think about the different equations of lines that we've learned already, slope-intercept form, that slope is staring you right in the face. Point-slope form, that slope is staring you right in the face. Standard form, well, you can't usually tell what the slope is without a little extra work. So if I look at these two equations in red, I can tell they're parallel because the slopes are identical. These are perpendicular because the slope, opposite, and reciprocals. So you can tell if lines are parallel or perpendicular just by looking at the form of the equation. So we're going to take a little example here. I have this line right here, but what I want to do is I want to write the equation of a line that is parallel to that line you see, and my new equation is going to have a y-intercept of 2. Well, if I think about y equals mx plus b, this is a perfect equation to use because I have the y-intercept. Remember, this thing needs the y-intercept and the slope. Okay, as a reminder, slope-intercept needs a slope and a y-intercept. Well, they gave us the y-intercept, and they didn't give us the slope, but they said it is the line we're looking for is parallel to the line you see here. So I'm going to figure out the slope of this line. In this case, I'm going to use rise over run. I go up 1, 2, 3. So my rise is positive 3. My run is to the right 1, so it's a positive 1. Rise 3, run positive 1. Keep in mind, if you had chosen this line or point and this point, you would have done a rise of actually negative 1, 2, 3, 4, 5, 6, and then a run to the left, or negative 2. But negative 6 over negative 2 is 3, just like 3 over 1 is 3. If the slope of this line is 3, then the line we're looking at, which is parallel to this, has a slope of 3. So from here I can say y equals 3x plus 2. This line is parallel to this line, and I could prove that by graphing it. If I put my y-intercept at 2 and my slope at 3, count up 3 over 1, or up 3 right 1, or negative 3 negative 1, you'll notice that the line that I'm graphing, 1, 2, 3, 1, ends up being parallel. This line is parallel to line A. Okay, and we're going to do one more. We're going to write the equation of a line that goes through, let me position this a little bit. Okay, it's going to go through point -1, 4. I know my graph is getting pretty messy now. -1, 4. So it's going through this line right here, but it's going to be perpendicular to A. All right, so now let's take a look. If it's going to be perpendicular to A, and I already know A has a slope of 3/1, the slope of my new line is -1/3. I also know that I have a point, -1, 4. That's the point they're giving me. And what I found out here is I don't have a y-intercept. I have a slope and a point, but the point is not a y-intercept. Perfect time for point slope, because I have a slope and I have any point. It just doesn't happen to be the special y-intercept. So when I have a slope and any point, I go to this form of an equation. And now I can say y minus 4 equals -1/3 x minus a -1. Minus a -1 is pretty clunky. So now I have an equation of a line that goes through that point and is perpendicular to line A. I'm going to pause the video and do a little sketch of this. Actually, instead of pausing it, we'll do the sketch together. We know this point. We know the slope is -1/3. So -1 for my rise, +3 for my run. Getting messy. -1 for my rise, +3 for my run. And if I graph that thing, and I can extend the pattern the other way, I notice that the line I just graphed is perpendicular. We use this symbol, perpendicular to line A. Okay, one last problem. We have a line that is in standard form, and we know that the line that we want to work with is going to be parallel to that line. And the line we want to work with has a y-intercept of 0, -2. So what is the equation of this line parallel to this y-intercept? Well, as soon as I have a y-intercept, I realize that I prefer to use y equals mx plus b because I need a slope and I need a y-intercept. They already gave me the y-intercept. So if our new line is going to have this for a y-intercept but parallel to this, I just need the slope, which means I need to figure out the slope of that line, and our line, which is parallel to it, is going to have the same slope. I'm going to solve for y to find that slope. There's my work for solving for y. I moved the 4x to the other side. That was my first step. And I divided by -6. It's a little tricky when you're dividing by that negative. A -4 divided by a -6 is a +2/3. That looks a little messy. Let me rewrite that. And then a +18 divided by a -6 is -3. But what I really care about is the slope of 2/3. So now I know my line, which is parallel to this line, has a slope of 2/3. They told us the y-intercept. So from this information, I can simply say y equals 2/3 x minus 2. Now I have the equation of the line parallel to that, because the slopes are the same, different y-intercept than that line. That is parallel and perpendicular lines.